Hey there, welcome back. In today's video on Python 3 basics, we're going to talk about three things: data, variables, and data types. So this whole video is about working with data in a computer. As I referenced in my last video, data is everything. So the way that you output data, the way that you work with data, the way that you input data, all these things are so important because that's what is the backbone of a computer program, is working with data in some way. So we're going to do three things. We're going to talk about data, variables, and data types. And for each one, we're going to show little examples to kind of further explain what I mean. To start off, we're going to try to answer simply what is data to a computer. Now, data is just information that can be represented slash understood by a computer. So, like I said, anything that a computer can take in, output, modify, uh, anything that the computer can verify or equate, any of those things, that's data, okay? Just data is information. That's all it is. And data is just an abstract way to quantify and qualify the real world in a computer program. So you're going to see in this first example that we use data to represent the real world. And that's kind of more of a high level topic to understand in computer science. And I never really hear it talked about on the lower level of computer science. So when people are learning how to program, like probably you who are watching this video, um, they just say, hey, make a variable, make this variable, make this loop, do this, whatever it is. But they never really explain, like, computer programs most of the time are representing real world data or abstract ideas or, measurements. They're always representing something. No program is ever made that just is random data doing random things. Computer programs take in real world information, or they simulate real world information, and they output some useful information, whether it's uh, the processes of a calculation, what to do with some data, what to information that's being stored long term for the real world via a computer or a database or something like that. So data is key. Data is everything. Anyways, let's break into the first example to show that data is representing the real world by just a simple little program. Don't worry about some of the things we're going to cover in this video. So I'm just going to do name equals Carter. So that's our first piece of data. I'll say age equals 24. And then I'll say loc for location, and I'll say Nanya. Yeah, we'll say Nanya. And then, so we have data here. We have data that represents the real world, and now we can do something useful with it. So we can print it out. Okay, this is obviously the most basic one. So we'll say my name is blank. I am blank years old, and name, age, loc. Okay, so we've got my name is going to be name. I am age years old, and I am currently at location, right? So if I go to run and I run this, we should see my name is Carter. I am 24 years old, and I am currently at Nanya, right? Don't want to be giving out your location on a YouTube video. That's the most basic thing we can do with our real world simulated data. The next thing that we can do with our data is we can, besides just outputting it, we can actually do evaluations on it. We can have the computer read the data, and if the data is of a certain value, we can do something with it. Now, I'm going to have a whole video on the concept of true and false, which is Boolean values, which we'll talk about later in this video, but we'll get much more in depth in another video. And then also if-else statements, okay? So you're going to see both of those. All we're doing is we're saying, if the data is a certain kind, do something. If the data is of a different kind, do something else, okay? So that's kind of the basic structure. That's a very basic but fundamental concept in Python. And like I said, I'm going to have a whole video on it here coming soon. So what we can do is we can evaluate the data. We can say if the age is under 21, then you can't buy beer. So I could say if age is less than 21, print, sorry, you cannot buy beer yet. And we'll make it a little bit nice. Maybe the person knows their name. And so if age is less than 21, we're going to print out a response that correlates to the current age. And we'll say else, because everything else above 21 can buy beer. So we'll say print your beer will be 1073. So now I can simply run this, and the computer is going to, again, it's going to evaluate the data that we have stored in our program, and we're going to do something useful with it. So if I go to run, you can see your beer will be 1073, and that's of course because our age is 24. So it's basically saying if 24 is less than 21, that's false, right? That's not a true statement. So if I turn it to be like this, let's say 18 trying to get some beer. So we're going to say if 18 is less than 21, I think you can figure out which output we're going to get. So it says, sorry, Carter, you cannot buy beer yet. Now that you know what data is on a very basic level, we can talk about how data is stored. And those are called variables. Variables are named containers to store data. We've seen variables many times already. I've just never kind of stopped to explain what they are. As you saw with the last example, we had 3 variables. We had name, age, and location, right? So the computer doesn't really care what the name of the variables are. I mean, it does, but it doesn't read it like you think. So those are for humans. So the variable name is for humans. I'll say var name, okay, equals 5, okay? This right here is the name of the variable, and this is the data. This equal sign is called the assignment operator. So we are assigning the value 5 to the variable name var name for variable name. And then, obviously I can do the same thing where I just print out data, but that's, not important at the moment. We can name this whatever we want. This is for the user or for the programmer to understand when they're reading the code. I could simply make variable name x equals 5, but then when I go throughout my program and I start using x in, remember, useful ways, then the computer will understand, if I have all the syntax and my logic is correct working with x. But if someone comes through and reads my program, or I come back in a few months and I read my program and I see x, I might not remember what x is unless I made maybe say x is coordinates, right? I could do something like that, but the name x for a variable is good when you're talking about coordinates, but it's really bad when you're talking about, we could say b days, x is really bad if maybe this was we can say something like that, you know what I mean? Not that this is necessarily correct at all, but what if we were storing a birthday in this kind of format right here? We could say x equals 05091998, and that works, and you can print that out. You can print x or whatever. You can I can't because it's let's make it a string because I can't have 0 in front of it. It was like, what are you trying to do, right? It says leading zeros and decimal integer. Literals are not permitted, so you can't do that. But we can put it in a string, which we'll talk about here in a moment. So we can store it as actually we can store it as text. So then we can do something like this, right? We could store a birthday. But again, back to the point is X is a terrible name for storing a birthday information because the programmer or the user or whoever comes back through and reads our code is not going to really understand what X is. So we could name it bday string. See, that's a lot more information for the programmer. So when they go through and they read the code and maybe they don't see the assignment or the assignment happens and the variable's been modified a bunch of times, it's really helpful to have the variable names named correctly and in a way that gives the reader more information. So that's a variable, and we can show that variables are persistent throughout programs. So variables are how programs store data long term to be used throughout a program. I should say throughout the same program because you can see that when your program is finished, there's no longer your variable. Your variable doesn't exist. When the program finishes, all the information is wiped from what's called the stack in the heap. All that information is lost, so it's not persistent over long term, but it's persistent throughout the program. So we can run something like this. I could say fav num equals 200. So we've set up a variable, right? We're storing 200 in this variable called fav num for favorite num. And what I can do is I can do something completely different. So my program's going to go off and it's going to, for I in range, we're going to do something 150 times. I'm going to print hello. So this is something completely unrelated to our data right here. I can say print. So then I can take this and I can print it here. So what we're going to demonstrate here is that we're storing data, we're outputting that data to show the value of it to the user, and then we're doing something completely different. So for 150 times, we're going to print out the word hello, and then you're going to see that the data stored in favorite numbers still exists once all the random, side work has been taken care of. So if I run this, you're going to see at the beginning, my favorite num is 200, so that's line 11 right here. And then the rest of this is 150 instances of printing the word hello. And then once that's finished, we're showing you that fav num still has the same value. Okay? Besides the advantage of having data store its value long-term throughout a program is the fact that throughout the program, we can actually modify the value of a variable. We've done this many times, actually throughout just the last two videos, of me just creating variables and then evaluating them and changing them. Let's talk about it a little bit more in depth now. So we'll talk about your favorite number, right? Let's simply change the value of the number. So I'm going to say, besides favorite number, I'm going to say current num. We'll say current num, and we'll actually change the name of our variable too. So we'll say current num equals 200. We're going to change it everywhere we need it. And then in here, let's change it. Let's add current num equals current num plus 1. So we're simply going to take 200 and we're going to add 1 to it 150 times. So we will be taking the value, so it's going to be 200, and then the first time it goes through, we're going to add 1. And then next time we go through, we're going to take the current value of number and we're going to add 1 to it. So you can see that we're going to actually modify this variable 150 times. So if we run this, let's see the output that we get. The current number is 200. So before the loop starts, our variable current num is 200, as you can see right here. And then after this block of code, the number has been modified 150 times. And so the current number is now 350. So we can modify program or variables. We can do so much to them. I could even do something like this. I could say current num equals hello. So maybe we print out do something like this. So you can see the current num is that value, and then we're going to change it to a string. We're going to change it to a completely different data type. So you're going to be able to see the current num is 200, and now the current num is hello. So Python's really cool because in a lot of other programming language you can't do that, or you have to do special things in order to get that result. So that's something you can think about too. Sometimes I make variables that need to be evaluated. So let's say we have current number that needs to be evaluated, and if current number is greater than 200, then we're going to change current value to, or current num to true, or we're going to change current num to false based on whatever it is. It's not necessarily the cleanest, most precise programming methods, but it's available and you can use it and you can actually do those things, right? Especially if you're doing your own little programs on the side. The final thing that we're going to talk about in this video is data types. Now, data types are the types of information that a computer can work with. In Python 3, there are 4 built-in data types that any program will understand with no extra work. Now, there's more than 4 built-in data types, but I consider these to be kind of the base data types, data that basically all other data in any other program is made up from. But for now, let's look at these 4 pieces of data that are so fundamental to every program in Python. The first one is going to be the whole number or the integer. So I can, what I'm going to do is I'm going to make a variable, kind of demonstrate what it looks like, and then I'm actually going to print it out. As you can see down here, the example says show data types using the type method. So what I'm going to do is I'm going to store a variable with each type of data, and then I'm simply going to print it out to show you that the computer actually interprets it as something else. So the first one that we have is the whole number, and that's an integer. So usually it's int for int. I'm going to call it int example, int ex, and so it can be anything. I can do -40, I can do -10, I can do 0, I can do what is that, 10,000? I can do anything like that, which is a whole number. That's what this data type is for, so we're going to stick with this 10,000. The next one is the floating point number or rational number, so that's going to be a number with a decimal. I can say float ex, float example would be, again, we can go negative numbers. We can do -199, right? 0.99. I can do 0.0001. Okay, that's a acceptable floating point number. I can do 5.2509, whatever it is. This data type is for storing number with trailing decimals, right? Fractional units, right? That's what we call those. This would be a fraction. So we'll leave we'll leave this float variable at that. The next one is the set of 1 or more characters or strings. So we've seen that as well. We've stored names and sentences inside, or parts of sentences inside variables, and that's what a string is. So I can say string ex, string example equals, and it can be 1 letter. It can be A if you want. It could be B. It could be C, D, whatever you want it to be. It could be much longer. It can be fox, That's only 3 letters, so that's not much longer, but it can be whole sentences if you want. It can be on the 5th of April, I took a walk. So we can leave it at that. And the computer will interpret it as a set of characters. Now, the final one is the Boolean value or the true or false value. And like I mentioned at the beginning of this video, I'm actually going to make a whole entire video on true or false just because I think that it plays well with when you start talking about the if statements, the if, elif, and else statements. So be looking out for a video about that within the next couple days of this video getting posted because it is a very important concept, but I think it's a larger concept, and I've talked a lot about these data types, or at least I've already kind of worked with these data types, and I haven't really worked with the true or false data type, so I really want to give it its own video. So Boolean, I believe, is named after the mathematician who worked with true false values, all these sets of true falses, like I'll get to them in the other video. I'll have more information to talk about it. But a Boolean is either true or false. Okay, it's binary. It can be two values, and it can't be anything else. There's no maybe or kind of. It's true and false. And based on true and false, you can get literally anything you want. Actually, every single thing in a computer system breaks down to true and false, which is, as I said, binary numbers, is either 1 or 0. So in computer science, in computer science and in Python, true represents any number and false represents 0. So we can say 1 and 0, that's true and false. So if I do bool example, I'm going to say true, just like that, with the capital T for true, or I can say false with the capital F. Now I can also do 1 or 0, but again, I will talk about that in the next video about Boolean values and if statements. So for now, I'm just going to put it as true, okay? So what are we going to do? I'm simply going to use this type method. There's this type method right here, which when we pass it each one of the variables, it's actually going to not return the variable data itself. It's going to return what kind of data it is. So I can do a print method like this. And why don't we do something like this? I'll say the var blank is of blank data type, right? Let's make it a nice output. Let's make it something interesting to read. So I'm actually going to copy this, and I'm going to print it 4 times because I have 4 variables. And then I'm going to take, copy, not paste. So the second value is going to be this type. I'm trying to be quick and I'm messing it up. So now we're going to print out the variable itself and then the variable type. So you'll see when we print this out, we're going to have 4 print statements, and each one is going to say the variable, 1000 is of data type blah, blah. So when I run this real quick, you're going to see the variable 1000 is of class int data type. The variable 5.2509 is of class float data type. The variable on the 5th of April I took a walk is of class string, str, string data type. And the var true is of class bool for Boolean data type. Okay, so you can now see that the computer interprets all of this data in different ways. Okay, I'm really not going to work with those anymore just because, like I said, I've done plenty of examples, I think, leading up to this in the past videos and in this video working with the variables. So doing it again really is not going to show any more information, I think, as of right now. So I'm going to wrap this video up here. Thank you for watching, and I hope that this information explained a lot to it and really helps you kind of understand Python in a different way.